Moving to the next question, find the shaded region. It's really very simple. But what are these four options that are written? Let me give you a simple idea about set theory. Let me be a George Cantor for a while. The concept mostly asks is A intersection B is equal to null set. Then what is the relation between A and B? What is the relation between A and B? I am giving you overview of some set theory. A intersection B is equal to null set. Then A and B are mutually disjoint. A and B are called mutually disjoint. Mutually disjoint. Mutually disjoint means their intersection is always null set. Their intersection is always null set. They are not overlapping set. Not overlapping set, or one can say not overlapping. Not overlapping means nothing in common, not overlapping sets. Their diagram must be like this. A and B have nothing in common. A and B have nothing in common. Such type of sets are known as mutually disjoint, or in loose terminology you can say non-overlapping, not overlapping, non-overlapping. Let me give you example as well. This is suppose odd numbers 1, 3, 5, 7 and so on. Taking even, 0 is also even, 0, 2, 4, 6, 8. They have nothing in common. They have nothing in common. So we can say that set of even integers and odd integers, they result in null set. These sets are mutually disjoint. These sets are mutually disjoint. Mutually disjoint. If two or more than two sets have nothing in common, these sets are known as mutually disjoint. They are known as mutually disjoint. They are known as mutually disjoint. Okay, then here. That is associative law. You must be familiar. A intersection B intersection C. Both sides have A intersection B intersection C. Where lies the point of difference? Where lies the point of difference? Try to understand. Here, bracket encompasses A and B. A and B. Here, bracket encompasses B and C. It means that it is going to start from very left and it is going to start from very right. Very right. First, compile A intersection B. Whatever the result is, find the intersection with C. Start from bracket. First, simplify the bracket. First, find A intersection B. Is starting from extreme left. A intersection B, whatever the result is, then intersection with C. It starts from left. And this one, first find B intersection C, then with A. Then with A. Starting from the very right. This is known as associative law for intersection. Associative law for intersection. Associative law for intersection. Associative law for intersection. Similarly, in the same token, if instead of intersection there present union, A union B union C, A is equal to A union B union C, again bracket to BC, bracket belongs to A and B. It must be start from extreme left. First find the union of A and B, then with C. In that case, first find the union of B and C there. It is known as associative law for union. Associative law for union. Associative law for union. Associative law for union. And finally, let me give you a good example of distributive law. A union B, here is intersection C, or A intersection B union C. Look at this. In associative law, both symbols are identical. Intersection, 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 intersection. While in union, there is also union. There is a difference. Union, there intersection. Here intersection, here union. It reads as distributive law of union over intersection. This reads as distributive law of union over intersection. Union over intersection. And this one reads as distributive law of intersection over union. Intersection over union. Intersection over union. It is union over intersection, and here it is intersection over union. How to write its right hand side? It's a not. Look at this. like multiplication, ordinary multiplication. Write A union B, A union, A union instead of in front of B as well as in front of C. Write A union in front of B as well as in front of C. Write A union in front of B as well as in front of C, like as this. A union B and A union C. This bracket, this symbol remains intact. It's our intersection. This is our distributive law of union over intersection. Union over intersection. Similarly, put A intersection in front of B as well as C. We have A intersection B and A intersection C. A intersection C. This union remains intact. This is known as distributive law of union over intersection. This is distributive law of union over intersection, while this one is distributive law of intersection over union. And let me finalize this one and moving towards the question after finding, after explaining De Morgan laws, De Morgan laws, De Morgan laws, De Morgan laws. De Morgan law states that De Morgan laws. Then coming back to the question, original question, De Morgan laws. De Morgan laws. A intersection B whole complement. Let me write C. It's tantamount to A complement union B complement. While the second law is A union B whole complement is equal to A complement intersection B complement. I used to write MCQs collect joining them together as A union B intersection C whole complement. The combination of both De Morgan laws. The combination of both De Morgan laws. Individual complement, union turns to be intersection, intersection turns to be union. A intersection B complements, union C complement. That is equal to this one. The simple application of De Morgan law. De Morgan law. Now our question says that we have given a Venn diagram of three sets, that is, and they have shaded this common portion, this very common portion. That is the portion that belongs to A as well as B as well as C. This is the overlapping portion of all these three sets, all these three sets, all these three sets. It is known as A intersection B intersection C. We have given a shaded portion here. Look at this. It is common to A, common to B as well as common to C. Common to A, common to B as well as common to C. This is our A intersection B intersection C. That is common to all. 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 That is our A intersection B intersection C. Let me share with you how to find, how to apply union and intersection for two sets or three sets. How to find their elements. It's really a cool concept. Number of elements in A union B is equal to number of elements in A plus number of elements in B, subtracting the overlapping elements. Subtracting the overlapping element. That is for two sets. If there are more than two sets, it's a wonderful concept. A union B union C. It means in a number of elements in all three sets. It's equal to number of elements in A plus number of elements in B plus number of elements in C, subtracting intersection of AB, BC and AC. 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 Subtracting the overlapping portion. A intersection B minus B intersection C minus A intersection C, and restoring the intersection of all these three and number of elements in A intersection B intersection C. This is for three sets. Three sets. How to find their number having in both A and B, in BC, in AC, or in all. That is the application of sets theory. Number of elements in AB or in A, B, and C in a real life. Moving towards next question, we have